And welcome to Unit 8 on geometry. Before we get into all the good geometry stuff, the perimeter and areas and volumes and all that, what we're going to do is just talk quickly about measurement and units and a little bit about unit conversion. So I'm going to try and go through this a little quicker than I normally would in the classroom, just because you can pause at any point to write down anything that you're missing. So I'm going to start by just kind of going through some of the common measurement units and how they relate to other measurement units. So I'm going to start by talking about the imperial versus the metric system. Metric, you may in science class hear the term SI or Standard International. It's actually Standard International or something. It's not English, it's French, I believe. But either way, metric and SI are very similar. SI is just kind of the overall scientific community accepted values for metric. Metric is just the system that's used all over the world, except for the US, who uses imperial, and us, who use a bit of it because unfortunately we get a lot of US media. So a lot of Canadian kids grow up watching US television, so we pick up a lot of this stuff. So for instance, even though we are a metric society, we use things like the height of people in feet and inches, which is imperial. The problem with the imperial system is that the conversion factors are incredibly weird, which we'll see in just one second, and that they were originally based on kind of arbitrary things. For instance, the American length of a foot was literally based on the length of a king's foot, and every time a new king took charge, they wanted to have their mark on things, so they defined their foot as the foot, which then changed the length of everything that had already been measured. Anyway, metric is much nicer. So what I'm going to do is I'm just going to start unveiling these. And again, you can copy these down as I'm talking, or if I'm going a little too fast, you can always just pause the video and copy them down later. But you're going to be using this sheet for unit conversions, so you are going to want these values. So when it comes to metric for distances and lengths, we tend to measure things in millimeters, centimeters, meters, or kilometers. We can measure things in less than millimeters, and people do, but not usually on a regular basis. So for instance, in science class, if you're using a microscope, you might use micrometers, or if you're a quantum physicist, you might use nanometers, which is the size scale of atoms. That's very, very small. There are things bigger than kilometers. We tend not to use them unless we're talking about things in space. Pretty much everything on Earth is measured in thousands of kilometers at most, because the circumference of the Earth is in the ballpark of thousands, several thousand kilometers. So either way, we could get into higher things like astronomical units and parsecs and light years, but unless you're an astronomy person, you're probably not going to use those things. Okay, when it comes to imperial, we also have a bunch of units. Inches, feet, yards, and miles. These tend to be the standard ones. There are some old English ones, some weird ones like furlongs that we don't tend to use. They may come up in some questions, but I would always define what they are within the question if that should happen. For those of you who aren't familiar with it, inches is usually denoted with the two little tick marks, much like a quotation. And feet are in one tick mark. So for instance, if someone was, just put it up here, if someone was 5'8", I could write 5'8" inches, something like that. But for the most part, it doesn't matter to me whether you use the tick marks, whether you use the word feet, foot, inch, whatever, or if you use abbreviations of those. If you use FT for feet and IN for inches, or just F and I, whatever you want to use in a question, as long as it's kind of makes sense what you're using, that's fine. So that we probably know from using rulers in our lives that 12 inches is about the same thing. Well, 12 inches is a foot. Your ruler that you would tend to use, the one that's relatively long, not the little short ones, are 30 centimeters or 12 inches. And actually that's going to lead us into the middle part. So I'll just bring that up now. If 1 foot was exactly 30 inches, if 1 foot was exactly 30 centimeters, then we'd have exactly 2.5 centimeters per inch. If you check a ruler, they're not exactly the same. So it actually works out to be 2.54 centimeters per inch. A foot, there are 3 feet in a yard. That's by definition. When it comes to the metric system, 1 meter is a little bit more than 3 feet. It's a little bit more than a yard. It's 3.28 feet. And in the imperial, the weird one that no one ever remembers is that a mile is made up of 1,760 yards. And a more common one is that 1.6 kilometers equals a mile. That comes in really handy if you're doing things like going between Canadian and US vacation. If you're traveling, distances in Canada are often measured in kilometers, and distances and speeds in the US are in miles. So the couple things I want you to note here. One is that the imperial system, while it kind of works, it has weird conversion factors. 12 inches in 1 foot, 3 feet in a yard, 1,760 yards in a mile, whereas the metric system is all based on base 10. So everything is 10, 100, or 1,000 times other units, or powers of 10 anyways. The metric and imperial equivalencies here in the left and right columns are exact. They're definitionally true. It's not like someone measured and said, oh, there's around 3 feet in a yard. A yard is actually defined as 3 feet. So those are exact values. However, the crossovers in the middle that convert between imperial metric, all of those have been rounded off just a little bit. So be aware that anytime you introduce one of those, you're going to get a little bit of rounding error. Don't worry too much about it. Just be aware that the answers you get are rounded off when you use any conversion between metric and imperial because they're not true definitionally. For instance, I think it's actually 1 mile is 1.609 something kilometers, but not enough to make a difference. So these conversions will do just fine for us. All right, jumping down to masses. Again, when it comes to the metric system, there aren't too many that we use regularly. 1,000 grams equals 1 kilogram. If you're in science class, especially if you're in chemistry, you may use micrograms, or if you look at things like how much nutrients or stuff are in vitamins or food, you may see things listed in micrograms. That would just be, or milligrams, 1/1000th of a gram or 1/1,000,000th of a gram, depending on whether you're talking about milli or micro. And then 1,000 kilograms is 1 ton. Now, some people may say, I'm sure I've seen the word ton before, and it was just spelled T-O-N, and you're probably absolutely correct. It turns out that for whatever reason, we didn't give it a different name, but we have a metric ton and an imperial ton. A metric ton is 1,000 kilograms, an imperial ton is 2,000 pounds. And I'm going to pop up the middle one here as well, just to point out that really the only conversion that we'll do to go back and forth is that 1 kilogram is 2.2 pounds. And what that means is that 1,000 kilograms is 2,200 pounds. So a metric ton, T-O-N-N-E, is slightly larger, 10% larger, than the imperial ton, T-O-N. Other than that, there's 16 ounces in a pound. We don't have too many other units to use. Again, there are other units out there. For instance, there's the old British unit of the stone, and a stone is, I believe, 14 pounds. It's, again, kind of a weird measurement to use, but there are lots of weird measurements out there. Volumes. Volumes are how much space something takes up in 3 dimensions. So basically, when it comes to volumes, and this is similarly true for areas, we can use all of the lengths that we saw up at the top here and then just square them for areas or cube them for volumes. And that's for the most part what we do, but there are a few unique ones. So for instance, when it comes to metric ones, we use 1,000 milliliters in a liter. And by the way, a milliliter is just 1 cubic centimeter. So if you take a little block that's 1 centimeter by 1 centimeter by 1 centimeter, that is by definition what a milliliter is. A liter itself is 1,000 milliliters. That's actually a 10 centimeter cube. So the amount of space taken up by 10 centimeters times 10 centimeters times 10 centimeters, which is 1,000 centimeters cubed, or 1,000 milliliters. That's a liter. You may be more familiar with a liter as half a large bottle of pop. That's the easiest way most people think about it. 1 cubic meter, so 1 meter by 1 meter by 1 meter, would be 1,000 liters. Each liter is 10 centimeters. 10 centimeters is 1/10 of a meter, so 10 of those by 10 of those by 10 of those gives you the 1,000 liters in a meter cubed. There's one that I didn't put on here, and I'll just point out for interest's sake, and that's that there is another name for the milliliter or cubic centimeter, It's short form. You might hear it in medical shows on TV. Whenever they're talking about giving out medication, you might hear, that the patient needs 20 cc's of whatever. CC is just short form for cubic centimeter. It's an American term, but it comes up quite a bit, like I said, in medical stuff. Okay, when it comes to the imperial side of things, this is where we get a whole bunch of them just based on mostly cooking. This is where you may have heard of most of these. In fact, that's where you've heard of almost all of these, if you've heard of any of them. I'm going to skip over those for just a second and go to the middle conversions because it's helpful to explain how they're related if we understand. So when it comes to things like measuring how much gas we have or even how much milk we have, we Americans tend to use gallons or quarts, and we tend to use liters. 1 gallon is 3.8 liters. Often people just use that a gallon's approximately 4 liters as an approximate transformation, like if you're doing it in your head. But 1 gallon is equal to 3.8 liters. And although most of you are too young for it, what you might know is that milk currently in most places comes in bags, at least in Canada. And the 3 bags that come together total 4 liters of milk. And that's based on the old Canadian plastic jugs of milk. And a jug of milk used to be 4 liters. And that's, again, based on roughly the American jugs of milk that were 1 gallon. So it's a little bit bigger, but a similar jug. 237 milliliters equals 1 cup. This one you may know if you remember back to when you were a little kid and you had chocolate milk or regular milk in those little wee cartons. The little cartons were 237 milliliters, and that's because it worked out to be 1 cup of milk. Incidentally, a lot of the weird numbers that you see on packaging come from American companies that package things and then convert into Canadian metric system or into just general metric system. It's not ours. So for instance, well, I'll talk about another one later that's kind of interesting. But anyway, yeah, also if you're a cook, you may know that 1 teaspoon is equal to about 5 milliliters. It's actually closer to 4.9, but if you're cooking, 5 milliliters is a perfectly reasonable approximation. Okay, I'm ironically going to start at the bottom of the imperial list to kind of go through these explanations here. It takes 3 teaspoons, which are the ones that you use to eat with, to make 1 tablespoon, which is the larger spoons that you serve food with. It takes 16 tablespoons to make up 1 cup. And then we're going to jump to the top here. 2 cups together equals a pint. You might be most familiar with a pint as how beer is ordered in bars. Not that you would, of course, ever been in a bar, but maybe you were out for dinner with your parents and they ordered a pint of beer. I'm going to go with that assumption. Okay, so a pint is just 2 cups. 2 pints together is a quart, and 4 quarts is a gallon. And what that means is since there's 4 quarts in a gallon and roughly 4 liters in a gallon, is that the American quart is actually extremely close to the Canadian liter, so they're almost directly equivalent, and that a pint of beer would be half of that. If it was half a liter, it would be 500 milliliters, and I think an actual pint is 474 milliliters, so pretty close. As far as the 16 fluid ounces goes, this seems weird because an ounce is actually a measurement of weight, not of volume. But just to give it an idea, if you think about what we've seen so far, a pint is roughly half a liter. A liter of water, by definition, is a weight of 1 kilogram, which means that half a liter of water, a pint, roughly, would be roughly around a pound, 1.1 pounds. And a pound is 16 ounces. So 16 fluid ounces is equal to a pint, in case you're doing any baking that uses that unit of measurement. All right, I think we'll stop there. Move on to areas. Metric areas, there's a unit here that you've probably never heard of. Some of these numbers you're going to be a little bit confused by because you're like, well, I thought you said there were 100 centimeters in a meter. And you're correct. There are 100 centimeters in a meter. But a square meter is 1 meter by 1 meter. And that means it's 100 centimeters by 100 centimeters. And 100 times 100 is 10,000. Similarly with kilometers and meters. If we take a kilometer is 1,000 meters. So 1 kilometer by 1 kilometer space is 1,000 meters by 1,000 meters. which is 1,000,000 meters squared. The one that you probably haven't heard of, and we'll talk about it in a second when we talk about prefixes, is hectares. So this is kind of the equivalent of something you probably have heard of, which is the American acre. And we still do a lot of property stuff in acres in Canada, especially farmland or larger properties. And this is kind of the metric equivalent of it. They're a bigger than an acre by a fair bit, but they're still kind of on the same size scale. And the way that they're defined is 100 hectares will fit into 1 kilometer square, which means that you get basically an area that's 10 squares by 10 squares within your kilometer squared, meaning that a hectare is really defined as 100 meters times 100 meters. So if you think about a football field being 100 meters long, if I took a square that had the same side lengths as a football field, that would be 100 meters by 100 meters, which is a hectare. Now, a regular football field is actually 60 meters wide, I believe. So a football field is about 2/3 of a hectare, the actual play area. If we go over to imperial, these ones, again, they come from the weird numbers. Since there's 12 inches in a foot, 1 foot by 1 foot is 12 inches by 12 inches, or 144 inches squared. Square yard is 3 feet by 3 feet, so that's 9 square feet. And an acre is the number that no one ever remembers. It's 4,840 square yards. Again, not a number that comes up particularly often. To convert between them, there's a couple that we use semi-regularly. It works out that there's 6.45 centimeters squared in an inch squared, which is just the 2.54 centimeters per inch, and 2.54 gets squared. 10.9 square feet in a meter. That one actually is fairly common, especially if you're ever buying flooring, because some places do flooring in meters and some places do it in square feet. And usually people just assume there's about 10 square feet per meter, per square meter. And then finally, a square kilometer is 247 acres. I didn't put it on here, but I do a lot of property searching. I'm looking for larger pieces of land to buy, which hopefully someday I'll be able to afford. But either way, I know that off the top of my head that 4,000 square meters is roughly an acre. So again, when we're doing unit conversions, you don't have to use just the ones I give you, unless of course it's on the test and I tell you to. But if you have any equivalency between two things, you can use that in our unit conversion method and it works just fine. Okay, so if you haven't copied all these down, pause the video for a second, take a moment and do so, because you are going to need them for the questions that we're going to do. And when you're done, move on to the next part. All right. Next thing I want to talk about is some metric prefixes. Many of these you already know, and the ones that you don't, you probably actually do know from different scenarios. There are more than just the ones here. I've actually put a little link to the Wikipedia entry in case you want to see all the extra ones, but we'll just stick with these major ones. And again, just to speed things up, I'm going to kind of do the same trick I used in the last one, which is highlight things. So if we talk about base units, for the most part, I'm going to talk about meters just because that's a familiar unit of measurement. We can talk about things relative to that. I'm going to jump around a little bit because some of them are a little bit more or less common than others. When we talk about smaller things like 1/100th, you probably are familiar with centimeters. So the prefix is lowercase c and the actual prefix word is centa. I know we say it's centa, like it sounds like it's an A there, but if you actually check the spelling, it's centimeters. 1/1000th of a meter, or 1/10th of a centimeter, you're familiar with as being a milliliter, or sorry, a millimeter. But it is also true for liters as your unit of measurement. Again, the prefixes can go with just about anything. And the one that you're most familiar with as far as the large numbers go is kilo, as in kilometer. Now, the few others you may be familiar with, we talked about this one already really quickly. Things that are on the 1/1,000,000th of a meter scale, or 1/1000th of a millimeter, are micro. And this is what microscopes do, is they look at things on the micrometer level, 1/1000th of a millimeter. Below that, you probably have heard this word more of a pop culture reference. 1/1,000,000,000th of a meter would be considered a nanometer. And you've probably heard the phrase nanotechnology. That's just technology that's designed to work at the nanometer scale. So nanometers is you're starting to get down to approximately the size of atoms. I believe a hydrogen atom is about a tenth of a nanometer. So it's even smaller than a nanometer, and most regular atoms are a little bit larger, but it's still on the atomic scale. I'm going to skip over the 1/10 and tenth because those tend to be the least familiar. Actually, the 1/100th, the 100 as well, and go up to the million. This one you're probably not familiar with in terms of meters because we don't talk about meters that way. Everything on Earth, like I said, is measured in up to thousands of meters, but not much more than that. Thousands of kilometers, sorry, I should say. But if you think about computers, you might be familiar with things that come above a kilobyte. So you have bytes, kilobytes, and then you would have megabytes. That's a capital M. And after a megabyte, you'd have a gigabyte. And most of you probably at this point know that if you put enough gigabytes together, 1,000 roughly, you get a terabyte. And then after that, you get, I think it's a petabyte. I'll be honest, I kind of lost track. It's something with a peck in it. Something like that. Okay, so the ones that people are least familiar with, probably the 100. Because again, when we're talking about meters or most things, we don't talk about, any special unit. We just call them hundreds of meters. But it turns out that it's hecto. And that's actually where the word hectare comes from for an area. A hectare is 100 meters by 100 meters. That's how I remember that one. 10 is probably the least heard of. It's deca. And depending on what source you look at, it can be spelled with a C or a K. Not that the spelling matters anyway, but I just thought I'd point it out in case you see differently. I think one of them is SI and one of them's just regular North American metric. Either way, either way you want to do it. And the official symbol for it is DA lowercase. I'd swear I remember seeing it as a capital D at some point, which makes sense since the larger things tend to be capitals and the smaller things tend to be lowercase. But either way, the official symbol is DA. Not that it ever really comes up in day-to-day life. The 1/10, again, we don't usually talk about 1/10 of a meter. Things measured in 1/10, we just say it's like 30 centimeters, which would be 3/10 of a meter. But you have heard this word in one other place, at least used properly, and that is deci. So what you probably didn't know is that sound is measured in decibels. Okay, well that part you probably did know. Sound is measured in decibels, or at least how loud the sound is. What you probably didn't know about that, though, is that the base unit actually isn't the decibel, it's the bell. A bell is the base unit of sound, but we tend to measure things in 1/10 of a bell or decibels. So decibel is actually a compound word made up of the prefix deca and bell. Okay, that's all you really need to know for these. As far as using them, they don't come up. Most of them don't come up a whole lot, but in case you do see them, you can always do a quick unit conversion between them. All right, now we're going to get it into converting units, and I'm going to start using my pencil now. My wonderful pen. Here we go. And I'll go through some things. First thing I want to do is make it clear that when we're talking about unit conversions, we're converting the way a number looks, but we're not making it bigger or smaller. Most people kind of understand that, and they're like, yeah, well, no kidding. I mean, for instance, if you have a toonie, that's the exact same thing as 8/4, despite the fact that 8/4 is larger than, like 8 is bigger than 1. But the unit quarter is smaller than toonie, and 20 dimes and 40 nickels. Those are all the same amounts, even though the numbers in front look different. The one place that this actually, most people don't get this, is that when we're talking about other countries and their currencies, we talk about like, well, a Canadian dollar is equal to like 200 Mexican pesos. And people are like, oh, they must be poor. It takes so many pesos to buy just like, whatever. I'm like, no. It's not, it has nothing to do with that. It's just an equivalency thing. That's like saying someone's rich because they have 1,000 pennies, whereas I only have $10. I mean, they're the exact same thing. The one number just sounds larger, so we think of it as being bigger. Okay, so I realize that the method I'm going to show you for unit conversion is likely new and it's likely overkill. In fact, for the first several questions we're going to do, it's complete overkill. But I'd like you to learn the method because it becomes extremely valuable when you do much more complex unit conversions. When we get to the tests on this, I'm going to let you use the kind of shortcut for regular questions. If you're just converting between, meters and centimeters, I don't care if you use this method. But if there's actually unit conversion problems, and I say the point of this question is to convert units, I will tell you that I want it done using the method that I'm about to show you. Okay, so here's how the method works. We're going to convert 1.62 meters into centimeters. And by the way, I do realize this is super easy and we don't need to use this method, but we're going to use the method to learn how it works so that we can jump to the higher questions without being confused. Okay, so I'm going to start by making something that I call a unit chain. And a unit chain says what unit we start with, which in this case is meters. And what I want to do is get this chain to centimeters, but any two things in a row, I need to know the relationship between. So for instance, I do actually know the relationship between meters and centimeters because there are 100 centimeters in a meter. This method becomes much more valuable when I don't know the direct relationship between two things and I have to use different central units to get from one to the other. But for now, let's just work on the method. Okay, so I'm going to start by writing down 1.62 meters. And I have one more unit to go, so I'm going to draw one fraction line. Now you probably are aware that the only thing you can ever multiply a number by and still get it to be the same value is 1. That makes sense. 5 times 1 is 5, 8 times 1 is 8, and so on. Which means that if I want this answer to be equivalent to 1.62 meters, this fraction better be equal to 1. And fractions are equal to 1 when the top and bottom values are equivalent. So for instance, 5 over 5, 17 over 17, 23 over 23. Now they have to be equivalent, but they don't have to look the same. So for instance, in this case, what I'm going to do is put centimeters on the top and meters on the bottom. And I know the equivalency is that 1 meter is 100 centimeters. Now note that I did not write, I didn't need to know whether I was going to multiply or divide by the 100. I just needed to look at it and say meters goes on the bottom, centimeters goes on the top, and 1 goes beside meter and 100 goes, 1 goes beside meter, 100 goes beside centimeter. Incidentally, the reason I knew which one to put on the top and which one to put on the bottom is because I want meter to cancel out top and bottom. So each fraction will have a bottom that's the same letter as the one before it. So if I was to do another one, centimeter would go on the bottom and the new unit would go on the top. And then that unit would go on the bottom and the next unit would go on the top, and so on. And once I've done that, this just becomes 1.62 times 100 centimeters divided by 1, but the divided by 1 doesn't do anything. So 1.62 times 100 is 162 centimeters. Let's do the same thing, but a little bit quicker with the 25 kilograms into grams. So again, I have a relationship between kilograms and grams. I know there's 1,000 grams in a kilogram. So I'm going to put 25 kilograms times 1 fraction. Kilograms was on the top. It now goes to the bottom. And the next unit goes on the top. And I know the relationship is 1 kilogram is 1,000 grams. And once I've canceled out the equivalent units, or sorry, the identical units, top and bottom, 25 times 1,000 grams is 25,000 grams. By the way, with ones like this, you don't even really need to do a unit conversion, to be honest, when you're going to actually apply this, because 25 kilograms, kilo means 1,000. It's 25 kilograms is literally 25,000 grams. All right, let's try one more like this and see if you see the difference this time. Okay, so milliliters, luckily we have a relationship between it and the next unit. So we know the relationship between milliliters and liters is that a liter is 1,000 milliliters. So 237 milliliters. I put milliliters on the bottom so that it'll cancel and liters on the top. And I know 1 liter is 1,000 milliliters. Now this time, unlike the last question, here we had 1,000 on the top. Now we have 1,000 on the bottom. But the good news is we never had to think about, do we multiply or divide by any number? We just put the units in and then put the numbers beside them, and it tells us what to do. So once we've canceled out the milliliters, this is just 237 divided by 1,000, because any number on the bottom of a fraction is just division. So 237 divided by 1,000 liters, which is 0.237 liters. Okay, that didn't seem too bad. I'm going to pause for a sec. Oh, and I'm back. Okay. Sorry, my voice was getting a little raspy there. My throat's getting dry. Alrighty, so we're going to move on then to the next question, converting into imperial, from imperial to imperial. So we're going to use the same method that we just used, and we're going to try and make it as quick and painless as possible. So again, we start off with feet in this case. We know we have 6 feet. We want to get to inches. We know the relationship between those, so that was a quick unit chain. So 6 feet. Again, I don't care what you use. If you want to write the word foot, feet, use the little tick mark, whatever. I just tend to write FT. And then feet has to go on the bottom and inches on the top. And I know the relationship is that 1 foot is 12 inches. Units cancel. You don't have to write out the cancellation of the units, but I'm just showing you that they do go away, leaving me with 6 times 12 inches is 72 inches. 4 ounces into pounds. I know that an ounce is related to a pound. And by the way, I don't think I mentioned this above, but pounds is horribly abbreviated into LBS. You'll see that a fair bit if you look at food packaging. LBS comes from the word Libra, I think, Latin, something to do with the balance, like a scale balancing, so weights. Either way, LBS is a pound. And if you prefer to write the word pound, by all means, feel free to do so. But what we'll do is we'll start off with our 4 ounces. And we'll multiply by 1 fraction. Ounce goes on the bottom. Pounds goes on the top. And we know that 1 pound is 16 ounces according to the sheet that we had. Once I've canceled out those ounces, I'm left with 4 divided by 16, which is just a quarter, or 0.25 pounds. By the way, a 4-ounce hamburger patty is a quarter pounder by definition. For those of you who are curious, quarter pounder patty at McDonald's is 4 ounces. People keep saying they get smaller over time. They've gotten smaller. They have not. They've always been 4 ounces, because 4 ounces is literally a quarter of a pound. The smaller patties that you may wonder about, like the ones on Big Macs or the cheeseburgers and stuff, those are 1.6 ounces. So it actually takes 2.5 of those small patties to make up the same amount of beef in a quarter pounder, which means that a Big Mac actually has less meat on it than a quarter pounder does. So what you're paying for is replacing some of the beef with an extra slice of bread and slightly different toppings. Just interesting fact. Okay, the next one, we're going to convert pints into gallons. Now this one might be a little bit more complicated, because if you look back at your original sheet and you've got your note in front of you, I'm not going to go back to the first screen, but if you do that, you might notice that there is no direct relationship between pint and gallon. However, there is a relationship between pints and quarts, and a relationship between quarts and gallons. So now is the first time our unit chain is getting a little bit more complex. It's getting longer, which means that we're going to have to do multiple calculations. Whether they're multiplications or divisions will be determined by the way that the question is set up. We don't have to think about, do we multiply the number or do we divide the number? So 14 pints is what we're starting with. We have 2 more units to go through, so I'm going to draw 2 fraction lines. Pint is on top, so I'll put pint on the bottom, quart on the top, and then quart on the bottom, and gallon on the top. And then I look back to my sheet, and it says here that 1 quart is 2 pints, and 1 gallon is 4 quarts. So I can say those cancel and those cancel. And then I'm left with 14 times 1 divided by 2 times 1 divided by 4 gallons. Now, when you're punching that in your calculator, you can obviously skip the multiplications by 1 or divisions by 1 should they happen, because they do nothing. But what I would recommend is hitting the equal sign in between, just in case your calculator does BEDMAS a little bit weird. So in this case, what I would do is 14 divided by 2, and then hit equals to get 7, and then hit divided by 4 equals, and you get 1.75 gallons. All right, so this is where the unit conversion method really comes in handy, is when we start to get into multiple conversions where we can't convert directly from one to the other. The one-step ones, like I said, on a test, if you're doing a question and something's in inches and you need to convert it to feet, you could probably do that in your head with one step. You don't need to do this method. But if it actually asks you to calculate or to use the unit conversion method, this is what I want you to use. All right, now let's do a couple of converting between metric and imperial. And this is where things can get a little bit more interesting. Okay, so the first one, we're going to convert kilograms into pounds. As it turns out, we have a unit conversion directly for that on our sheet, so we don't need to worry about it. And then I just do 125 kilograms times kilograms on the bottom, pounds on the top, and my sheet says that a kilogram is 2.2 pounds. Cancel those. 125 times 2.2 is 275 pounds. When I was teaching this in class, one of the students said, "That's a lot of pounds." And I said, "Yeah, that's the amount I weighed when I was 14 years old." I wish I could still weigh that. But anyway, that's an old number. The next one, this one's where we're going to get even a little bit more interesting. And you'll notice that I'm leaving a little bit more space here for this one. 3,000 yards into kilograms. So what I'm going to do is I'm going to set up my chain. I have to get from yards to kilograms. So I'm going to go from, if I look at my sheet, the way to approach this is basically look at your unit conversion list and look for the word yard anywhere, and then see if you can get from yards to kilograms. So in this case, I think I can get from yards to feet, because I know there's 3 feet in a yard. I can get from feet to meters, because I know there's 3.28 feet in a meter, and I can get from meters to kilometers. Okay, so that wasn't too bad. I found my unit chain. Now this chain happens to be 4. And if you were trying to do this one manually in your head, you'd have to just know whether to multiply or divide each of those numbers properly, and you're probably going to get at least one of them wrong. So we're going to use the method. So we'll start off with 3,000 yards. I realize Y is the official short form, but to me that's years, so I like to use YD. 3 fractions because there's 3 more units. And I'm going to do a quickie way this time. Instead of doing bottom top thing, I'm going to look at my unit list and just say yard was started. And then we go to feet, meters, kilometers. And on the bottom, we just shift over yard, feet, meters. And there'll be no kilometers on the bottom because I don't want kilometers to cancel out. I want kilometers in my final answer. Now that I have all the letters in the right places, I'm going to go back to my list and say 1 yard is 3 feet. 1 meter is 3.28 feet, and 1 kilometer is 1,000 meters. So as it turned out, multiplying by 3, dividing by 3.28, dividing by 1,000 would be the right answer. I'm going to cancel out all the units that cancel, which is all but kilometers, because that's what I want. And I'm going to punch this into my calculator as 3,000 times 3, and then I'll hit the equals to get 9,000. Divided by 3.28, hit equals, I'm at 2,743 something, and then divide that by 1,000 and hit equals, and get 2.7439. Now I'm going to point out that normally I wouldn't keep this many decimal places. This is a distance in kilometers that's accurate down to about 10 centimeters. That's way more accurate than we need to be. But the reason I'm going to do that extra decimal places is because, well, you'll see in a second, because I'm going to show you the uh, other way that I could have done this problem, the reason that I left extra spaced. So our unit conversion chain was yard, feet, meters, kilometers. But I could do a different chain. And in many cases in real life, there's going to be several chains that'll work as long as they start with the unit you have and end with the unit you want, and any two of them in a row you have an equivalency between. And it doesn't matter what the equivalency is, how you got it. Um, if you look at somebody's driver's license and you say, well, it says that they weigh this many kilograms and I know they weigh this many pounds, then you could use that as an equivalence because you know that they're equal. You don't have to use the ones off the sheet, unless of course it's on the test and I tell you to. But anyway, let's try a different unit chain from our sheet. So if I look back up to the top again to look for where yards appears, I could have also gone yards to miles because I have a relationship between those. And actually I have a relationship between miles and kilometers. So it turns out that I could have done a unit chain that only had 3 units in it instead of 4. Now I will point out when you're trying real questions, what might happen is you get to a dead end. So you go from feet, yards to feet to whatever, and then you're like, crap, I can't find anything that gets me to the unit I need. Try going back to the original unit and start off in a different direction. So instead of like in the first one, we went from yards to feet. Second one, we went from yards to miles. Sometimes if you use a different starting path, you'll find a different way to get to the end that's efficient. Because sometimes you just don't have an equivalency between the units you're hoping for. Okay, so we set this one up the same way, and we should get the same answer. You'll notice again, I put those extra decimal places up there. This one only gets 2 fractions. So here we go on the top, yards, miles, kilometers, and on the bottom, yards and miles. By the way, I write out the word miles because I don't want to confuse it with meters. And then I know that yards to miles, 1 mile is 1,760 yards, and that 1 mile is 1.6 kilometers. So cancel those, cancel those. And in my calculator, I'm going to do 3,000 divided by 1760 equals times 1.6 equals, and I get 2.7272 kilometers. And I want to point out that the 2.7 part is the same on both, but this is a little bit different. And this has to do with the fact that we're moving between imperial and metric. And one of them, I have the approximate number of feet in a meter. And one of them, I have the approximate number of kilometers in a mile. And because of that, there's slight rounding differences. It's not going to be enough to matter, but I just wanted to use the extra decimals here to show you that sometimes you'll get slightly different answers depending on which chain you do, because anytime we're using approximate equivalencies, you're going to introduce some error, and you're introducing a different error depending on which path you take. But again, if they're more or less correct, it'll be fine no matter which way you do. All right, one more. Now, this one, I'm going to just kind of mention something that I said earlier, which is that I know in my head that when I'm looking at properties, 4,000 square meters is roughly an acre, which means that 84,000 divided by 4,000, which is 84 divided by 4, which is 21. This should be approximately 21 acres. So that was just a quick calculation I did in my head when I'm trying to, like, again, looking at a bunch of properties on Realtor, and I want to see roughly how many acres they are. But let's actually do the proper conversion. And in this case, we have a relationship between meters squared. Do we know how many meters squared are in an acre? And I don't think we do. But we do know meters squared to kilometers squared and kilometers squared to acres. All right, so let's start off with 84,000 meters squared, 2 fractions, kilometers squared acres, meters squared, kilometers squared. And I know from my table that 1 kilometer squared is, that's that's 1 million meters squared. And I also know that 1 kilometer squared is equal to 247 acres. So what I want to do is cancel those. And in my calculator, I'll do 84,000 divided by 1 million equals times 247. And that gives me 20.748 acres. Okay, so again, that there is some rounding error there because there's not exactly 247 acres in a square kilometer. Anytime we go from imperial to metric, there's a little bit of a rounding error. But I do know that my very quick approximation, it was a number that wasn't on your list, but it was a number that I know off the top of my head, gave me an approximate of 21 acres. This is pretty decent. I'm off by a couple percent, but I still have a pretty good idea how big the property is just by that quick calculation in my head. Okay, just a couple more questions to finish things off here. Let's take a look at a couple of multi-step unit conversions. So some of them are going to be more obvious than others. For instance, here we've got convert 5 foot 10 inches into centimeters. So obviously there's some mixed units there. So let's see what that one looks like. First thing I'm going to do is realize that 5 foot 10 inches is already mixed units. We have two different units there. So we've got a couple of options. We can convert 10 inches into feet and then do feet to centimeters, or we can do 5 foot into inches and then do inches to centimeters. And since we have a unit conversion for inches to centimeters and it's actually nicer to do, that's what I'm going to do. So what I'm going to do is convert my 5 feet. And again, I'm just going to do a quick feet to inches. 5 feet times, we put inches on the top, feet on the bottom, and it's 1 foot is 12 inches. And I think the total there, once we've canceled out a couple things, is going to be 60 inches. Okay, so that's our 5 foot. Now we do our 60 inches plus our other 10 inches is 70 inches. And finally, once we have that, we can convert 70 inches into centimeters. My pen's doing a weird drag thing. Not sure what's up with that. Hopefully it doesn't bother you too much. 70 inches. You know what? I'm just going to quickly reset my computer and see if that helps. Okay, it seems to be slightly better, but let's just see how it goes. We do 70 inches multiply by one fraction line, inches on the bottom, centimeters on the top. And we know that 1 inch is 2.54 centimeters. Cancel out the units that appear top and bottom. Multiply 70 times 2.54 and we get 177.8 centimeters. Okay, that sounds about right. Part B, this is a different type of multi-step unit conversion. This is one where we actually have what seems like two separate units because, well, it is two separate units. So a car goes 400 kilometers on 50 liters of gas. What is the gas consumption in miles per gallon? So here's the issue, is that we have basically two things. We have 400 kilometers that we're trying to convert into miles, but we also have 50 liters that we're trying to convert into gallons. And so what we're going to do with a question like this, with compound units, which is essentially means a unit miles per gallon made up of two separate units. So let's just treat it as two separate problems. We're going to convert 400 kilometers into miles and 50 liters into gallons. So the first one is going to be kilometers to miles, and that one's a relatively straightforward conversion. 400 kilometers times miles on the top, kilometers on the bottom, and our relationship is that 1 mile is 1.6 kilometers. Units cancel, and we're left with 400 divided by 1.6. which would be easier if I can punch into my calculator correctly. Gives us 25 miles. That is definitely not correct. 400 divided by 1.6 equals 250 miles. Okay, and then our other conversion is liters into gallons. And same idea, we start off with 50 liters, liters on the bottom, gallons on the top. And we know that 1 gallon is 3.8 liters. Cancel out those units. And 50 divided by 3.8 is 13.16 if we round. Again, we're switching between metric and stuff, so it's going to be a little bit of rounding anyway. 15.16 gallons. So now to finish this off, what I'm going to do is basically state the original question, which was 400 kilometers per 50 liters. And that's equal to 250 miles, which is 400 kilometers, equaling 15.16 gallons. And then I just use my calculator to simplify that by doing the division of 250 divided by 15.16 is 16.49, or let's just say 16.5 miles per gallon. Okay, so sometimes we have that where we have 2 units in one question, convert both units separately, and then put it back together at the end. This last one is a different type of compound unit again. It's basically taking an area, but it's giving things as separate measurements. So in this case, we have a landscaper needs to sod a lawn after it was dug up to replace some water pipes. This, by the way, is based on a real life story of what I had to do to my lawn a couple of years ago when one of my pipes burst. The rectangular lawn is 50 by 30 feet. That's actually roughly what my lawn is. And sod is sold by the square meter. So what is the area of the lawn in square meters? Now there's 2 ways you can do this one. I'm going to show you just a kind of a different approach. You could multiply those together, find the area of the lawn in square feet, and then just do a straight up unit conversion. But I want to show you how to approach some 2D and 3D problems if you ever get something that's a little bit more complicated. So what I'm going to do is just draw a quick little picture here. And here's my lawn, and it is 30 feet by 50 feet. And then what I'm going to do is at the side, I'm going to convert both of those independently as linear distances or lengths, not areas, but just as lengths, into their metric equivalent, into meters. So I'm going to do this one pretty quickly, just because we've done a bunch of these and because I don't have a lot of space left here. 30 feet. Actually, sorry, I'm going to leave myself just a little bit more room here. 30 feet. I should use the FT. It's nicer with the unit conversion method. And we're going to do feet and meters. And I know that 1 meter is 3.28 feet. So the answer to that is just going to be 30 divided by 3.28 is 9.15 meters. And then separately, I'm going to do basically the same calculation, but with 50 feet times 1 meter over 3.28 feet. And then that one should just be 50 divided by 3.28. And that gives me 15.24 meters. Then what I'm going to do is just go back to my diagram and say I labeled the sides 30 by 50, but I also could have labeled them 9.15 meters by 15.24 meters. And then if I want the area, I just focus on my new values in meters instead of my old values in feet. So the area of the lawn is 9.15 times 15.24, which is 139.446. We'll just do 139.4 meters squared. And if you ever have to do this where you're trying to find, say, for instance, the volume of a rectangular prism or something more complex than do a unit conversion, what you could do is just convert the individual pieces you were given in the first place into the units you want, and then do the geometry on them normally. Okay, so that was a very long lesson compared to most, although I don't think it was a particularly hard one. At least that's my impression, but it's up to you to decide whether or not it was difficult for you. But I would like you to try some of the practice problems here, and most of these are just unit conversions. For those of you taking this course from another school, which in e-learning is quite possible, Eastwood is the school that I teach at, and it actually is fairly accurate here with the lengths and measurements. But anyway, give these a shot, and please be aware that the answers at the bottom are approximate. And the reason for that is because, first of all, there's always going to be rounding error when you're doing calculations like this. But also don't forget that anytime we're switching back and forth between imperial metric, any of our approximation factors or any of our equivalency factors are already approximated in some way, shape, or form. So if you're slightly off, don't be too concerned. Maybe on this first one, you get 80.2 and I've said 81, and if it's close, you're right. When you're doing these kinds of unit conversions, if you do something backwards or upside down or something like that, you tend to get extremely wrong answers, not just slightly wrong answers. So you'll know it when you see it. Anyway, give those questions a shot, and then when you're done, if you're still having problems with it, by all means contact me. And if you're understanding it and getting those answers correct, fantastic, and it's time to move on to the next lesson. Until then, have a great day.